Today we will learn about linear symmetry and rotational symmetry. Look at this figure. Can you tell whether this shape is symmetric or not? Think. Let us tell. If we draw a vertical line from the center of this shape, then this line divides the shape into two equal parts that are mirror reflections of each other. That is, they match each other very accurately. Thus, when a line can be obtained by folding the figure in two equal parts such that two parts become symmetrical, then the shape has linear symmetry. Therefore, this shape has linear symmetry. That is, this shape is symmetric. Similarly, we can also draw a horizontal line in this shape which divides it into two equal parts which are mirror reflections of each other. We can say that it is also a symmetric line. Apart from these two lines, there is no other line that shows linear symmetry in the figure. Therefore, we can say that this figure has two symmetrical lines. In rotational symmetry, the shape of the figure is the same before the rotation and after the rotation. Now think, does this figure also have rotational symmetry? Think. We will show a point on this figure to check for rotational symmetry. Keep in mind that this point is not part of the shape. If this shape is rotated around its center, we can see that at a rotation of 180 degree, the shape exactly matches the initial shape. In the same way, we also see that this shape at a rotation of 360 degree again meets the initial shape. Therefore, we can say that this figure has rotational symmetry. Since the shape in a whole circle is twice the same as the initial shape, we can say that the figure has rotational symmetry of order 2. Thus, this figure has both linear symmetry and rotational symmetry. Now look at this shape and tell whether it has linear symmetry and rotational symmetry or not. In this shape, we cannot draw a symmetrical line in any way, so that we get two parts of the shape which are mirror reflections of each other. In this way, we can say that the figure does not have linear symmetry. Does it have rotational symmetry? Think. Absolutely right. A dot will appear on this figure. Keep in mind that this point is not part of the shape. We see that at 180 degree rotation and 360 degree rotation, the shape corresponds to the initial shape. Since the shape on 360 degree rotation corresponds to the initial shape twice, we can say that the figure has rotational symmetry of sequence 2. Now let's talk about this shape. It is a circle. There are infinitely many points on the circle. If we draw any line from the center of the circle, then that line divides the circle into two equal parts which are mirror reflections of each other. In this way, the circle has linear symmetry. And infinitely many lines can be drawn from the center of the circle. So we can say that the circle has infinitely many symmetrical lines. Similarly, we will show a point on the circle to check for rotational symmetry, keeping in mind that this point is not part of the shape. Now we can get the figure exactly as it was from the initial shape by rotating the circle through any angles like 0.1 degree, 0.5 degree, 1 degree, 10 degree, 80 degree. So we can say that the circle has infinite order of rotational symmetry. Now you must try yourself. How many symmetrical lines are there in a hexagon and what is the order of its rotational symmetry? So today we learned about linear symmetry and rotational symmetry. We will get to know it better by some examples in the next video. Today we will see examples related to linear symmetry and rotational symmetry. In the below given figure, find whether linear symmetry and rotational symmetry of greater than order 1 are there or not. When the two sides of the shape are coincident, when the shape is folded along a line, that is, one half of the shape is a mirror image of the other half, then we can say that the figure has linear symmetry. Here the vertical line divides the shape in such a way that the left half of the shape is a mirror image of the right half. Hence, the figure has linear symmetry. The line along which we see linear symmetry when we turn it is called a symmetric line. In this figure, the vertical line, horizontal line, and slant lines are also symmetric lines. Rotational symmetry in a figure occurs when after rotation, the shape appears as before according to the position. If during a round rotation, only once the shape matches the initial shape, that is, as before, then we say that the figure has rotational symmetry of order 1. But if the shape matches the initial shape 2 or more times while rotating, then we can say that the figure has rotational symmetry of more than one order. Here we see that if we rotate the figure at an angle of 90 degree around the center, then we get the figure exactly matching the initial shape. Similarly, if we rotate the figure at angles of 180 degree, 270 degree and 360 degree, then in these cases also we get a shape matching the initial shape. In this way, there are 4 positions in an entire circle of the shape when the shape looks the same as before. So we can say that the shape has a rotational symmetry of order 4. Thus, the given figure has both linear symmetry and rotational symmetry of more than one order. Next example, draw the rough shape of a quadrilateral which does not have linear symmetry but has rotational symmetry greater than one order. A parallelogram that has no right angle and has different lengths of adjacent sides is an answer to this question. Can you tell me why? Think. Let us tell you. This is a quadrilateral in which we cannot draw any symmetrical line. That is, it does not have linear symmetry. But if it is rotated around the center at an angle of 180 degree and 360 degree, then we see the same shape as before. Since in a complete round, twice the shape appears exactly as before, we can say that it has rotational symmetry of order 2. An answer to the question given in this way is a parallelogram that has no right angle and the length of the adjacent sides are different. Can a rhombus be the answer of this question? Think. Let us tell you. Two symmetrical lines can be drawn in a rhombus, so it has linear symmetry. But we need a quadrilateral that does not have linear symmetry. Therefore, this is not the answer of the given question. Think about all types of quadrilaterals and discuss with your friends and find out which quadrilateral has how many symmetrical lines and the order of rotational symmetry. So today we have seen examples related to linear symmetry and rotational symmetry. A few more examples will be seen in the next video. Today we will see a few more examples related to linear symmetry and rotational symmetry. Rahul and Manisha were discussing the figure shown below. Rahul believed that in this figure there are two symmetrical lines and rotational symmetry of order 12. But Manisha believed that there are 6 symmetrical lines in this figure and rotational symmetry of order 6. Find out whether Rahul's understanding is correct or Manisha's. Here Rahul definitely has drawn a vertical line of symmetry and a horizontal line of symmetry and thought that the figure had 2 symmetrical lines. Rahul had forgot to draw more symmetrical lines. Similarly, all the corners must be counted by him, which is 12, and it must be understood that there are 12 corners, so the order of rotational symmetry will also be 12. This is also a misunderstanding. So we can say that Rahul's understanding is wrong. You may remember that if two parts of the shape become coincident when the shape is folded along a line, then there is linear symmetry, and that line is called a symmetrical line. You can draw a symmetrical line in this shape. First in this way, second in this way, the third in this way, fourth in this way, fifth in this way, and sixth in this way. No more symmetrical lines can be drawn in it. So we can say that the figure has 6 symmetrical lines. To check for rotational symmetry, we will draw a point on the circle. Keep in mind that this point is not the part of the shape. You will also remember that if the shape rotates and it looks like before, then the shape has rotational symmetry. In a complete turn of 360 degree, the number of times an object looks exactly the same is called the order of rotational symmetry. Here, after rotating this shape at 6 angles like 60 degree, 120 degree, 180 degree, 240 degree, 300 degree, 360 degree, etc., rotational symmetry appears. In this way, we can say that this figure has a rotational symmetry of order 6. From this, we can now say that Manisha's understanding is correct. Example 2. Complete the table given below. A horizontal line going from the middle of the letter C of the English alphabet divides it into two parts so that the upper half and the bottom half are the mirror image of each other. Therefore, we can say that it is a symmetrical line. Other than this, no symmetrical line can be drawn on C. So we can say that C has only one symmetrical line. Similarly, we rotate C. We see that only once on a rotation of 360 degree, we see the same shape as before. So we can say that C has rotational symmetry of order 1. Similarly, you fill the row of N yourself. Now, look at this shape of the third row. Can we draw a symmetrical line in it? Think. All right. No symmetrical lines can be drawn. So the number of symmetric lines in this figure is 0. Similarly, if we rotate this shape at an angle of 120 degree, 240 degree and 360 degree, we get the same shape as before. Since during the rotation, we can see 3 times the figure appears as before. So we can say that this figure has rotational symmetry of order 3. Now complete the table yourself for all the given shapes. So today we have seen a few more examples related to linear symmetry and rotational symmetry.